everyone, thank you for coming. I'm Munir from ParaSwap. I will let you with the superstars of the hottest topic in DeFi today, MEV and Front-Running. So I won't keep you too much. This is a great night. So we'll start with the panel. Then we'll have a cruise, as you saw in the agenda. Then party will last till 1 a.m. So I hope you enjoy, and I'm gonna let you guys take it from here.
Thank you, everyone. My name is Seine. I'm not a superstar. I'm into Shutter, which is a project where we try to prevent front-running, which is a type of MEV, and one of the, hopefully, I think the worst kinds of MEV. Maybe, okay, some discussion to follow. Maybe to start, to review, oops, that's 2 slides. Yes, so what is front-running? If you send a transaction today in Ethereum, it will not get included into the chain immediately, but rather first has to pass through this peer-to-peer network. And in this peer-to-peer network, represented by this dark forest metaphor that someone came up with, anyone can see that it was sent, and they can try to send a transaction and get that transaction in first. They might do this because they can extract value from the fact that they know that the microphone is not working? No, sorry. That the other transaction will follow. For example, if the other transaction buys something on some exchange, this will increase the price, and if the front runner buys first, they can benefit from that knowledge. So how do we prevent this? Very simple, we simply encrypt the transaction. Then, in theory, front-running is still possible, but you can't extract any value from the knowledge that the transaction will happen because it's there's no information there that you can read. And then only later, when the transaction is already included in the block, and the order of these transactions is finished and something can't get in first, the decryption key will be published and the transaction will be decrypted and executed. Where does the key come from? To do this encryption and decryption. Closer?
Yeah.
Oh.
Perfect.
Sorry. It's impressive. So it can't be the user to pick the key because the user could simply decide to not decrypt the transaction in the end. That's and we don't want to give the user that power. So what we do instead, we have this group of keepers, which is like a decentralized set of nodes, and they provide encryption and decryption keys using a distributed key generation protocol. And this ensures that the transaction will always be executed eventually, as long as this set is honest. So this technique is now very general and can be applied in different circumstances, in different settings. The most obvious one is a blockchain itself. It could be a layer 1 blockchain, could also be a layer 2 chain, like a rollup. And that's probably where the technique would work best. It could also be used in centralized institutions, for example, in some centralized exchange. They have also big front-running problems, and if they would use such a technique, they could make themselves safer. And finally, it can be used on Ethereum. We've implemented this technique as a kind of a smart contract middleware, and if your application only accepts transactions that came through that middleware, they would be front-running protected. That's all from me. Thanks.
Cool. Yeah, I will talk to you about CowSwap, which is our solution to MEV. And let me start with the problem. On the left side, it might be a little bit small to see in the back row, but we can see DEX trades that are happening in some random block on Ethereum today. And what we can see there is that 2 trades that are on the same token pair in the same block, even using the same protocol, so for example Uniswap, end up getting different clearing prices. And this comes from kind of the mechanism that Uniswap uses, in that it has some state, and when one transaction is applied, it updates that state, and then the second transaction sees the new state. So the ordering of transactions within the block matters. And kind of this price time priority principle that depending on when your transaction gets executed, that has an effect on your price. That might make sense in traditional finance, where most of the trading mechanisms come from, because there you have a continuous market. You can actually say, well, we are trading every millisecond or every nanosecond, and even there people say maybe we should have some form of batching and some form of uniform clearing prices. But on Ethereum, where we only have new information every 15 seconds, where everything that happens within a block happens at the exact same time, it doesn't make sense to have a price time priority principle in the trading protocols, and we should not have different execution prices for trades on the same token pair. And so CowSwap basically does not do that for you. If you have the same token pair trading in the same block, you will always get the same execution price. We will batch orders into, well, a batch auction, and then clear all of them at the same, well, fair execution price. And what fair means, we can go into a little bit more detail. But really the difference being that if you trade on CowSwap, you don't have to play any games, you don't have to try to get in first or get in behind somebody who's moving the price in your favor a lot. You will get, everyone gets the same price, and it's matching supply and demand at basically the best level. Just if you compare different solutions to MEV, you have kind of some solutions attack the base layer, like for example what we just heard with DKG. That's something you put probably in your L0 almost kind of blockchain. You have on an infrastructure level, that's where I would put Flashbots at the moment, and also some other protocols like MistX and ArcherSwap. They are not really changing anything about the way trading is done. They're just providing an infrastructure to have more granular communication maybe between the miner and the trader. And then you can have MEV solutions or MEV mitigations on the dApp layer on the actual trading protocol. And that's where Gnosis protocol and CowSwap, which is an application on Gnosis protocol, falls into. So there's two main core ideas of how we can make this uniform clearing prices batch options work. The first one is kind of a necessary requirement, is that we need to get users to stop sending their transactions directly via the public mempool to the miners. With MEV, we have seen that miners are not acting in our best interest. If you just put your transaction in the public mempool, they will take it and try to maximally extract it. So instead, what we should do is we should give our transaction to some third party that will act in our best interest. In the example of Flashbots, these would be there's the Flashbots, not public mempool, but basically the MEV Geth incentivized mempool. In traditional systems, you would maybe call these relayers. In Gnosis protocol, the trusted party is called a solver. And the reason it's called a solver is because all you're giving that entity is your intention to trade. You say, I want to buy this asset for this asset at that price. You don't commit to a concrete path which liquidity you would like to use. If you're into Uniswap or Balancer, you don't care about that. You just say, I want to trade this asset for that price. And then what the solver does for you, it checks at the time of execution, what is the best path that I can take, and then executes your intent to trade on your behalf. And what this allows the solvers to do is not only settle each individual trade in one single Ethereum transaction, but instead it can start to aggregate different intents to trade together and match them all in a single Ethereum transaction and apply certain rules, like, for example, a uniform clearing price. The second idea, and that's kind of where the name CowSwap comes from, is the phenomenon of that we call coincidence of wants, or the abbreviation would be COW. And that kind of happens when two people want to trade the exact opposite asset roughly at the same time. Let's take, for example, if somebody is willing to sell USD for ETH and somebody is willing to buy ETH for USD. Today, in the very same block, what would happen is they would both trade against Uniswap. Uniswap's reserve at the end of the block would exactly be the same as they were at the beginning, but the liquidity providers would have gotten a nice fee, although all they really did was provide a sponge, an intra-block liquidity source that wasn't really necessary. On Gnosis protocol, we can instead match these people directly against one another, peer-to-peer if you wish, and that is what we call coincidence of wants. And now you might say, well, this happens very rarely, people won't trade the same asset at the same time. There is a slightly more advanced version of a coincidence of wants, which would basically take if you dissect all the trades that are happening on chain and even take, like for example, if you're trading Curve against USDC, most of the time you will first trade Curve against WETH and then WETH against USDC. That will happen kind of under the hood when you go via Balancer or SushiSwap. And then if somebody else was trading a different token pair, let's say USDC for GNO, they would also go via this intermediary WETH token. And in there we can see that there's a coincidence of ones, even just on like a subpart of the execution path. And if you dissect blocks like this, you can actually see that there is a fundamental amount for coincidence of ones, at least assuming that, well, we get most of the order flow routed through Gnosis protocol. We can actually achieve significant improvements on people's price, because for every dollar that we don't have to use external liquidity, we don't have to pay a market maker or a passive liquidity provider for it, and we can pass that price improvement on to the user. And so just to summarize, the MEV protection that comes from Gnosis protocol or CowSwap is twofold. The first one is if we have a coincidence of one, then we match this inside our protocol directly peer-to-peer. So it has a similar MEV protection like 0x RFQ orders or other off-chain agreed prices. There's no MEV that can be extracted from that because it doesn't depend where in the block our settlement transaction is mined. It's also maximally gas efficient and it saves LP fees. So that is kind of the holy grail. We want to maximize the amount of cows. However, of course, initially we won't have the majority of DEX volume on Gnosis protocol, and until then, basically all the excess, all the amount that cannot be traded peer-to-peer, will go on the entire liquidity pool that Ethereum offers. So any on-chain DEX liquidity can be used. So we're integrated with 1inch, Matcha, ParaSwap. And so even like in the worst case where nobody else is trading with you in the batch, the protocol still kind of defaults to a meta DEX aggregator, giving you the best price at that moment of trading. And yeah, that's CowSwap.
Sorry about that. I used this one. I was trying to record it from you. All right, so I'll say a couple of words about Flashbots. Flashbots is a hacker collective. We do research and development to try to mitigate the negative externalities of MEV extraction. There's several areas within Flashbots. We do many things. Part of what we want to do is illuminate the dark forest and democratize extraction. So we have a data part where we collect information about the extent to which MEV is being extracted. Have two dashboards up. One is explore.flashbots.net. There we have lots of numbers of general MEV activity. Then we have another dashboards.flashbots.net. That's more for Flashbots usage and the bundles I'm going to tell you about in a second. And then another big part of Flashbots is research. We have a research program for what we call FRPs, Flashbot Research Proposals. Those are MEV-related research projects, and we give grants to researchers working on these topics. Several things there, designing auctions that can encompass for different preferences, cryptoeconomic solutions to privacy, cryptographic solutions to privacy. We have like a big list of topics of things we either work on or would like to be working on. And this is like a community effort. We try to coordinate those, but most of the research projects themselves are undertaken by the community. And then finally we have the auction. That perhaps what created what was mentioned before. We have a fork of Geth called MEV Geth that's now run by 85% of the miners, which essentially enables a new API that takes Flashbots bundles. The bundles are ordered sets of transactions that the searchers, those like looking for MEV extraction opportunities, want included in blocks. So if you're a trader, you see, I don't know, an Oracle update, and you want to liquidate the position that will become unhealthy after this Oracle update, so you can bundle the Oracle update with your liquidation and send that to MEV Geth and pay a price to the miner, and the miner will include that as an atomic thing. Right now we have a relay where searchers actually send the bundles to our relay and we forward them to miners. This is to ensure we don't spam the miners. We don't have privacy yet, but this is in our roadmap. We have one project to have MEV SGX using secure computation, for those that are familiar with that. And we have other plans to more in a research stage to try to solve privacy either with cryptography or crypto economic incentives. This with ETH2 is going to change a little bit because we will already have the bonds of validators, so perhaps we can leverage that. So yeah, that's sort of Flashbots in a nutshell, and I think I'll stop there so we can get going with the panel.
Is it?
I think you have to, if you have to turn it on, but it's gonna blow up. I tried that and.
Should I take it?
We need an MC here.
Should we not use this mic? Okay, we can only use one, I guess.
I can take care of the thing.
Should we just share a microphone? Okay, maybe we're expert here.
Can you turn it on?
Should I turn it on?
Yeah, turn it on.
Okay.
Test. Yeah, okay.
Test.
Test.
No, I think it worked.
1, 2, test.
Yeah, that's good.
Test.
Test.
No, yeah, test.
Okay, are we good?
All right. We have expert here.
Just matching the colors.
Yeah.
Yes, you can disinfect if you want this.
We have more there.
Perfect.
Okay, good. Yeah, and then let's go into hopefully a panel discussion. I will keep my question short because I definitely want to involve you guys. But first, a topic I want to talk about are risks. What do you see as, maybe asking you individually, what do you see as the biggest risks or the topic you might be concerned about in this MEV space? Who wants to start?
Okay. So I think the main topic that we all have in mind, especially since like a couple of weeks, is reorgs and time bandits. So I think this is the most threatening thing because they could threaten finality. So I don't know if everybody is familiar with what we call a bandit attack. So I'm going to describe it briefly. So the idea is that if there's a lot of extractable value happening in a block, say because there's like a huge liquidation, right? And we see.
I think probably one of the biggest ones are hacks, actually, smart contract hacks.
Hacks, but we've seen liquidations like 100 ETH, 300 ETH.
Oh, well, we have seen bigger hacks.
yeah, hacks as well. So yeah, any big like big MEV opportunity. Sorry, I'm confused. And yeah, so any big opportunity incentivizes miners to, instead of mining on the longer chain, to actually rewind the chain and go try to remine that block that had all the extraction and keep that money for themselves. Maybe even leaving some money out so that future miners are incentivized to mine on their chain rather than on the longest canonical one, right? So the problem there is that if miners enter a race to try to capture that value, you never achieve finality, right? Because it's like they're all trying to capture that, and the change essentially stops. So I think this is the main thing that can be threatening. The other MEV things I think are dangerous or less than dangerous, are problematic for users, like prices going up. But I think this is the one. I think this will be solved by I was saying then there's a post by Vitalik and Georgios today on this. So after the merge, but until the merge, there's a looming risk. I don't think it will happen because I think like miners have a social cost to pay, so I think they're aware and that they're not into that game. But anyway, I think this is the main one to keep an eye on.
Yeah, maybe you can comment on this more. To what extent is it fixed with the merge?
Yeah, I'm not super aware of how the mechanism works, but like in the merge, after the merge, what we have is finality that's decided. Like it's not probabilistic, right? So you have, once the attesters have like vouched on a block, there's that's final, and you cannot rewind past that block. So in a sense, you cannot have reorgs all the way to the many blocks.
Sure, but that also takes a while. So, but maybe then we should have this discussion with these two research. Yeah, then, well, staying a minute at this reorg thread, I guess, to what extent could a solution like Shutter, could that address this this issue?
I'm not sure. I don't think so. I think Shutter also, like at least this on-chain version we built, suffers from that is attacked by this too. Like in what we do in this on-chain Shutter is we accept transaction until a certain block, and then this batch is closed, and then the decryption key is released and we execute. And if an attacker can reorg now beyond this batch closing bound, then this mechanism is even broken. So no, Shutter is damaged even more by that too. That's only for this on-chain Shutter mechanism. Yeah, if it's used in a layer 1, I think it's not it's not the case anymore. But it also wouldn't help, in my opinion, against this reorg issue that we see.
Right. What would it take to add something like Shutter to Ethereum itself?
So I don't think Ethereum will do that ever, or should do, mostly because it adds another trust assumption. You have to trust this set of keepers or nodes that they are, or the majority of them are honest and produce keys when they should do and not earlier. That's why I don't think Ethereum will do it, but other layer ones probably will and already do.
Although I also don't really expect that maybe, but on this argument I would say, well, we have the validators anyhow, and kind of, well, then they could also perform that role.
Yes, and other blockchains do that. Like, there's some chains which try that.
Yeah, to what extent is that topic within Flashbots to kind of fundamentally reduce, well, MEV on a protocol level?
So you're asking to what extent we at Flashbots try to do that? Yeah. So yes. Right. No, so
It's crazy, right?
no, it's perfect, but so I think we do for more in the longer term. So we are working on how MEV on ETH2 will work, and if we can think of strategies to reduce MEV at the protocol level in Ethereum too. And there was one presentation, I think it already happened by Thomas, who's with us, and also Nethermind. So on one way we're working on doing this. So I think, but some things can be done, and we're doing research on them, but more for the long term. In the immediate, shorter term, so we have some of our research topics are on dApp design, and how can dApps, or how should dApps do to minimize MEV, but those are not the ones that are most active now, because it's the ones that we have less collaboration to. So we are for reducing MEV by all means. We think that there's some MEV that cannot be avoided, and that we might as well like extract efficiently. It's not that we don't want less MEV.
Felix, maybe involving the EU. So, do you have an opinion on this question? To what extent, where to address the problem on protocol level versus on an application specific layer? And yeah, maybe to what extent is or the batch solution can that, like, how general is that, or is this limited to this DEX use case?
Maybe first of all, I would like also to say how CowSwap would act in like a reorg, under a reorg attack, because I thought that was interesting, and I think that we would actually be defended against that because needs to be a little bit known how our solvers work, but basically there's a network of multiple solvers that are competing for the best solution. And then there's like an off-chain communication who gets to, well, settle the current batch. And that happens before the transaction is mined and before the block is mined. And so even if there's a reorg attack, this competition would not be restarted. And so the solver who has won the original batch auction settlement rights would still have those rights and wouldn't be able to change their transaction after the fact. So once something is settled on Gnosis protocol, even though there could be a reorg attack on Ethereum, the solver that submitted the solution is not allowed to change their solution after the fact. Your second question was, and how far or where do we stand on the layers? I think I just run brief slides on where we could attack or address MEV, and then yeah, there's the layer 0, the protocol Ethereum base layer, which is probably the hardest to change, and we see with things like EIP 1559 or other things where basically the entire community is behind it, how long it takes to make these fundamental changes to the base layer, just because it's such a valuable protocol, and we are kind of reluctant to make changes to it. So that's why I think it's very it's somewhat unlikely that we'll find a base layer solution in the next couple of years, and we see the numbers from Flashbots. MEV is already there. It's a multi-hundred million dollar business. And so this is why, well, at Gnosis we have from the beginning tried to build auction mechanisms that are less prone to, initially it was just front running, but now recently also back running, sandwiching. So yeah, for us it's very important that we build protocol steps that try to minimize MEV. And it's also something that Phil Dahan was already referring to in his 2018 talk when Flashbots 2.0 came out. And basically since then, we've always tried to build protocols that can minimize it. To the question, how far can it generalize from just trading? So I agree with you that there will always be a certain amount of MEV present on chain, but at least for any kinds of asset transfers, may it be investing your salary into some diversified portfolio, going into a Uniswap position, lending out stuff, anything that is tokenized, anything that, and it might not be just a one-to-one swap, it could be a more expressive order saying that, okay, I have this bag of tokens and I want something that assembles kind of this target allocation, or even like I'm indifferent between USDC or USDT, just give me some stablecoin that I like. All these kinds of swaps, and I think you can actually model a lot of use cases with that, can be solved with these batch auctions.
Cool. My next question would be, do you expect that we will have a public mempool as we used to have it in 1 or 2 years?
Okay, so maybe giving more context, so it's already definitely happening. So basically all 3 projects would kind of go away from that. So with Shutter, you wouldn't submit it to the public mempool, you would submit it to Shutter. With Gnosis protocol, you don't submit it to the public mempool, you submit it to this kind of special order format. And with Flashbots, you also don't put it to the public mempool, you put it to whom exactly?
To us. So yeah, no, it's a great question. But so in the timescale you gave, I think we have to think of it ETH2, right? Ethereum 2. And there we have a critical piece of infrastructure that we do not have now, that it's validator keys, right? So you could in principle do things like encode your transaction to the key of the validator and have only the proposed validator for a block unlock that. So I think that changes a lot the landscape for how things will work. So again, this is very much research right now. We're thinking about different things in which this could be leveraged. To have like a better MEV extraction and perhaps less MEV. So in that sense, okay, it's public still, but it's encrypted to the validator that has the ticket too. So I think that's like the future that's most likely to play out, I would say. Yeah.
I mean, I don't know, it's a long time, but my guess is that there will be still a public mempool, simply because there's many types of transactions which are simply not affected by MEV, or for them it doesn't really matter if anyone sees them. So simply value transfers, for example, if you just want to send money to someone, it doesn't really matter if someone front runs you or not. So, and for all of those, it's a public mempool is totally fine.
True, for simple transfers, that's certainly the case. Do you
Do you have data on this? How many? What's your guess? What percentage of transactions are affected by MEV? 2%, 5%, 50%?
No, I cannot put. So right now, half of, like ballpark, half of blocks are used by bundles. So this is like
wait, so half of the block.
Yeah, more or less that.
Wow.
Yeah, it fluctuates a little bit, but yeah, or how much? No, sorry, I gave you the wrong number. Half of the blocks have bundles.
Okay.
This is like a much milder number. Yeah, I don't know how big the bundles are approximately, but I would say like more 20 to 20%. Take that with a grain of salt, though. So yeah, still that's like a proxy measure for what you're asking, right? It's not exactly the same. So
no, I mean I think if a transaction is in the bundle included, it should be quite light. I mean, okay, of course there are other ways to.
But you also have the extraction there, which takes space and that distorts things a little bit.
And you might also have. I think there have been by now other use cases where you, I mean, even just saying kind of I only want to pay if my transaction succeeds, that alone, even if there's no MEV whatsoever, is already used kind of a something where you can use Flashbots for.
Yeah.
Cool. Then I would open it up also to the audience. Are there questions, comments, maybe also? Okay, cool.
If I may ask.
Yeah.
Are there in the CowSwap solution? Thank you. Hello, Andrew here. In the CowSwap solution, how do you ensure that no one can, or if the price changes externally, and as I understood it, you already settled the prices of the swaps, and the price drops everywhere else, how will it turn out? If you wait until the batch is closed and then execute it, wouldn't the people that traded through you get a horrible price? I mean, not the market one.
Okay, I'm not entirely, so basically I'm going to answer the question first how I understood it, but maybe you were answering it, were you answering it with regards to the reorgs or just in general? Just in general, okay. So the order that you sign through right now through the CowSwap interface is effectively a limit order that is taking the current price estimate plus some slippage, like I think 0.3% in the default case, so just exactly what you would place on Uniswap. But then let's assume you're the only one person in the batch. There's nobody else, so we need to settle your entire trading volume against on-chain liquidity. There's no coincidence of want. Then our solvers would compute the best route at execution time. So what we do is we wait right now about 30 seconds if we can find a cow for you. If we can't, then we will match you against the best on-chain liquidity. So we'll compute the best route. And then our solvers set an extremely tight slippage bound for these interactions. And so at the moment, we are setting 0.1% slippage, but we're integrating with the MEV Geth client, and then we can even set 0% slippage tolerance on the transaction that actually happened from within the contract. And if that happens to fail, then the solver will just run again, basically. The solver will recompute the best execution, and as long as your limit price is met, they can just retry. And this is another benefit of actually delegating your transaction to a professional party, is that you're not paying unless your trade goes through. Just signing this order is free, it's just an off-chain signature, and then only when you trade, part of your trading proceeds will be paid out as a reward to the solver. And so the solvers are professional parties, they know how volatile is the market right now, is our trade going to go through or not? So they can really optimize things that the average MetaMask or retail trader cannot match.
Hello, this is another question for CowSwap. Is it possible to have a trade partially fulfilled by a cow and then partially fulfilled by on-chain liquidity, or is it all or nothing?
No, totally. And that's also, like the first example I showed you, of course, that's like a textbook example that never happens, or very rarely, unless you maybe have a market maker that is deliberately taking the other side. But usually you will have one trade that is larger than the other trade, And so we will fill the smaller one directly, completely with a cow, and then the larger one will settle as much as it can via the coincidence of want, and then all the excess is traded against the best on-chain liquidity.
What happens to Ethereum when the Flashbots server goes down?
No, nothing. We're not a solver in the sense that we don't extract MEV or look for MEV extractions. We just relay bundles of transactions from the searchers, which is like any search, and you can be a searcher, whoever wants to submit bundles to a relay that's open, and we just forward those to the miners. And so we don't search or extract value ourselves. So we're not a solver in that sense. And if the relay goes down, and we've been under attacks recently, and perhaps the relay is clogged for some time, but nothing happens because the miners still run their own MEV get, and that's on the miners. So MEV get adds the capability of receiving bundles, but still preserves the normal interface of receiving transactions. So you can, so it doesn't change anything for Ethereum. Users can still submit transactions to an endpoint, and they will get picked up by miners in the same way as they did with regular get. So, yeah, nothing. The only thing that would happen is that no bundles would be mined. So searchers extracting MEV won't get their extractions, but nothing else.
Question for Flashbots. Could you please elaborate a bit on the part where you said that ETH2 would mitigate or solve the issue of reorgs?
So again, I'm not super familiar with the finality gadget for ETH2, but the TLDR is that the validator, once you have enough attesters attesting to the validity of a block, that block is considered valid and there's no going back. So right now we have probabilistic finality in the sense that if enough people are in agreement, they can rewind the chain as far back as they wanted to. So if you had a massive amount of GPUs because you discovered, I don't know, a new material that gets you 1,000 more powerful GPU, you could rewind the chain. This is no longer true in ETH2. Once a block is final, it's final, and you cannot change it. So yeah, that's how it works. So, but again, I encourage you to check the post today by Vitalik and Georgios, where I know they make an argument for that. That's elaborate.
Anyone else with a question? Thank you.
One question to Yannick for Shutter. You said that Shutter is not preventing the attack when you have the reorgs, but this would mean that somehow these attacks must be blind, random attacks constantly to Ethereum, to see if after some blocks then again the secret is unveiled, and then to see if there was something interesting inside. Did I get it right?
Yeah. Yeah, basically the attack would be wait until you see the decryption key, then you know the content of all transactions, and if there's something front-runnable there, which probably will be, reorg and introduce or add your own transaction to the pool.
But then Ethereum would be broken if people would do this all the time.
Yeah, kind of.
Okay. Yeah, that's one more.
That's for CowSwap. How would I know that you're acting in the best interest of the user and not arbitraging the batch transactions and giving everyone basically a worse price than instead of some people getting a better and some people getting a worse, everyone just getting a pretty bad price and you're benefiting off of it?
Yeah, that is a great question. Basically, the answer is that there's a competition between solvers. So the entity that you send your transaction or your intent to trade to is just basically a public order book. And then we have multiple solvers trying to find, it's a bit like searchers are trying to compete for what is, they're trying to optimize something. And what we try to optimize in CowSwap is not the amount of value we can extract from the traders, but quite the opposite, the value that we can add to each order on top of their limit price. So one thing to consider when you have batch auctions is that in opposed to classic order books, where when you place a limit order and you get matched, you will get matched exactly at your limit. In batch auctions, the clearing price will be at least your limit price, but in most cases it will be better than your limit price. And the difference between the execution price and your limit price is what we call a trader surplus. So it's basically how much price improvement did we give you on your limit price. And when we sum the entire trader surplus together of all the traders that are in one batch, we have a metric that kind of captures how much value are we giving to our traders. And this is something that the different solvers can compete for. And then we have like a communication channel where they compare their results, basically saying, I have a solution that achieves this much surplus, I have a solution that achieves this much surplus. And then assuming that we have a viable competition, and at least 3-4 solvers that are running this competition, you can be quite sure that unless they collude and really try to, collude to extract value from you, the best solution, the one that maximizes trader surplus, is the one that we will be getting picked. And so this basically this competition and this objective criterion, which is also a little bit more complicated than what I sketched here. If we just maximize for trader surplus, there's a possible attack vector with fake tokens, but we have on our forum, we have a bit more of a research discussion on how this objective criterion has to be chosen. But that's basically, we optimize for something, and then if we have the competition, you're guaranteed to maximize that value for traders.
And who are the solvers? Like, how do you choose who can be a solver? And how, maybe I didn't get it. How do they make money? Like, where do they save money?
Yeah. So how do they make money? The protocol is taking a fee. We haven't yet decided if we take a fee on the trading volume or only on the surplus that we generate. That would be a nice kind of thing to just say we only take a fraction of kind of the benefit, the value that we add to the user. But basically there's a protocol fee, and that fee is shared between, the protocol itself and the actors that provide value to the protocol, in this case solvers. And who are those solvers? Well, right now, how can you become a solver? Right now, unfortunately, you still have to speak to us to become a solver, so there's a whitelist or an allow list in the smart contract. But Gnosis is a DAO, and we are fully committed to building this protocol out fully decentralized. And the plan for that would be that the DAO would basically enforce a set of rules that solvers need to comply with when it comes to, for example, one basic example is uniform clearing prices. One other example could be, you cannot pick prices that are too far away from, let's say, the current Uniswap ETHUSD spot price. So even though there's like some weird batch where maybe that you can find some surplus at a very weird price, you have to at least arbitrage out the Uniswap pool to make the on-chain Uniswap price reflect what this new price update is. Some soft rules like this could be imposed by the DAO, and then anyone who posts a bond, the value has to still be decided, but a significant bond into kind of a bonding contract can become a solver, and can then, as long as they play by the rules of the game, earn a share of the protocol fee. And if they violate some rules of the game, then the DAO can penalize them, slash them, and if there's harm that has been created for users, the penalty can be used to reimburse the users.
I have one question for our panelist, since he asked all this nice question to us. So I'm all for the batch auctions. So my question is, why do you think these are not used in the traditional financial world, like Wall Street, for instance?
Yeah, good question. There's this famous paper by Buddish, and actually he did after that. So basically, there's a paper where he lays out why there's some theory that says, batch auctions would be better, and then I think 1 or 2 years later he published another paper showing the incentives of the current market participants, and basically pointing out that currently those who run the marketplaces don't have an incentive to switch because they make good fees by whatever this co-location thing, where kind of they allow specific traders to be very close to. So basically, the whole industry evolved around MEV in a way. So around high frequency trading, and the incentives are simply not currently there to well, cut this industry out. So I'm a little bit wondering to what extent we will see this in Ethereum. Maybe there my slightly provocative question around to what extent are we interested still in reducing MEV compared to building an industry around exploiting MEV?
Yeah. One other point there is also that in traditional finance we come from this continuous trading mechanism, and so time price priority makes sense. But in Ethereum we start like Ethereum is already batched. We already have blocks. We have batches in and of itself. So it makes much more. It seems much more sensible to apply batch auction mechanism there than in traditional finance, where you first have to decide, well, what is a reasonable batch time? Do you take 1 millisecond, 1 second, half an hour? Like there's a lot more open questions, and on Ethereum it just really fits. Like it seems very, very clear that it's more fair to give people like a uniform clearing price than just based on some random ordering within a block.
Please say your concerns.
No, I agree with all you said. Yeah, I'm all for batch auctions, as you said. I'm like a huge fan. So yeah, hopefully we can incorporate them at a protocol level to some extent. I don't know what can be done still at protocol level. Like I think with Ethereum too, we have like a big opportunity to introduce changes. So today I was talking about 1559, for instance, and how that interacts with MEV, and I was making the claim that perhaps if like 1559 was designed with inclusion of option in mind, and in fact we have other things. They have like ordering and privacy and other things people want, and that wasn't sort of taken into account in the design. So
I very much agree with this conclusion. So unfortunately, 1559 was designed at a time where, kind of the current form of block creation, or the form back then, the form of block creation or block options for block space were quite different. And actually, in my view, unfortunately, we are losing one quite nice pattern with 1559 now. So basically, over the last months, various projects have started this kind of zero gas price, because then you can submit a transaction with zero gas price, and you pay basically the miner within the transaction. And again, the nice thing for the user is they have a guarantee that they only pay if the transaction is successful. And that will at least become much, first impossible, or you could hack it a little bit with 1559, but in general you would not longer be allowed to create, to submit, or zero gas fee transactions would simply no longer allowed to be included.
But on the other hand, this also, this opened up an attack vector, and I think Flashbots right now, one of the reasons why they're centralized is to prevent spamming, and if you cannot tell before you evaluate a transaction if it goes through or not, if it's valid to be included in a block, that in and of itself also attacks the trustless execution model of Ethereum.
I would argue at this point, well, worst case, but you can always decide to ignore them. So that's always possible.
By introducing a karma score or something like that, you have some heuristic.
Just in general, like if you run your miner, you can always decide to say, I will basically ignore all those transactions, and kind of it's just more an opt-in. You could do it, and it might be useful to do it. Well, then maybe last question, and then okay, 2 more questions, and then let's have a vote.
So I was just wondering, in the layer, with these two, but in a roll-up centric world where we have most of the stuff not anymore on layer 1, how do you see all of your projects actually looking like? What's the future in that aspect?
So for L2s, you mean?
So if most of the actual transactions are happening in L2, how is it even as relevant with MEV on layer 1?
Yeah, so there's 2 MEVs, right? MEV in sequencing the transactions that go into the L2, and then the MEV that happens in L2. So this varies from L2 to L2. Some have, like, for now, centralized sequencers that take care of this, so they could in principle extract the MEV themselves. You could have operators extracting MEV in the L2 itself. So it's very varied. It's like a zoo. We have one, so I mentioned before the Flashbots research proposals. So we have one Flashbots research proposal investigating precisely this question. So hopefully I will be able to answer more fully this soon. We're planning on publishing some posts in, I would say perhaps later this month or also like an exploration and all of this. This is done with many external collaborators, so it was a great effort of like joining people from the ecosystem and trying to think of the different L2s. So I don't think there's one concise answer to that because it varies a lot. But yeah, I think there's going to be these two L2s, and how these are extracted will depend a lot on each one of the L2s.
But it's the user can pick the L2 they want, which is the variable.
Yeah, the user, but they're also constrained that where is the protocol that, right? So it's like perhaps, I don't know, you want to use like Uniswap, and Uniswap is deployed in Optimism, and so you have to use Optimism. And so yeah, it's a match of user and protocol. And yeah, perhaps it might mean that users start choosing protocols not for the protocols themselves, but for the L2s they're deployed on that layout. Yeah.
This is for CowSwap. Sort of one of the major problems for like your project is to try and get you need as many people as possible to use it, so you can get as many clouds as possible. What's one of your main ideas to go down the route? Do you currently have a token, or are you thinking of like a swap mining thing or something like that? What's your thoughts on trying to increase cows?
Yeah, so I mean, CowSwap is a Gnosis founded project, so CowSwap is part of Gnosis, and Gnosis has a token. Historically, we have had trouble convincing people that are excited about one of the Gnosis products, like Gnosis Safe, Gnosis Auction, CowSwap Now, to actually take the Gnosis token as an investment vehicle for that. And what you said is it's completely right. There was actually a very nice Twitter thread of from Hazu 2 or 3 weeks ago, when should we do a token? And one of the points when you should do a token was if you have very strong network effects. And CowSwap obviously has extremely strong network effects. But we hope that there will be a batch auction protocol on top of Ethereum, but there might only be one. And so we want to be that protocol. And so there is, Martin actually did a forum post in the Gnosis forum to propose, should we build a separate token for CowSwap? And well, at the end of the day, it's up to the GNO holders today to give away control of the product they own to the community. And so, well, I can just encourage everyone to express their mind and give their opinion. But yeah, it's very likely that we are definitely considering a token. And then just in terms of other things that we could be doing, we're looking into an affiliate program to basically have people gain some form of monetary value. That could be in GNO token, it could be in whatever trading tokens whatever sell token you trade, or in a CowSwap specific token. And then last thing, well, we are also then thinking about incentive programs. On our end, it's a little bit different than maybe the classic ones where you get incentivized for liquidity provision, because we tap into all the liquidity that is already on Ethereum. We don't really need new liquidity. So it really needs to become a trader incentive program. And there, watch trading is a big problem. So yeah, we are considering different mechanisms. But yeah, we have some cool ideas, and stay tuned.
Thanks for that.
Okay, last question.
Thanks. Question to CowSwap. So when you talk about the business of DEXs and swaps, right, you have pretty much the two sides. So you have the traders who are after the lowest fees and lowest slippage, and then you have the liquidity providers who are actually after higher yields. You're introducing this third element, third players who are actually trying to arbitrage in between the or I don't know what the term would actually be, the proper term for these guys here, and where's the margin coming for them? Given the fact that, are these the guys who are actually channeling the liquidity, but then why would they cancel higher yields on the exchanges that they're having already, or what's the business there?
Right. So basically the question is who's winning and who's losing if CowSwap was the only DEX protocol on Ethereum. I would say the people that we really want to get rid of are, well, people that extract value by doing intra-block arbitrage and basically, well, everything that's happening, the MEV extractors, basically, this is the kind of value that we want to reduce to zero. And then who is going to be the benefiter of basically that? It would be, well, traders would benefit from better prices. And then you were specifically talking about cows and what happens when people trade peer-to-peer. In that case, well, we would again give the benefit back to the traders. It's a little bit like we had this metaphor when you go to the airport and you're trading, you know, your euros for US dollars at the trading station there, and about half the people are flying to Europe and about half the people are flying to the US, and so you know you're paying this huge spread at these airport exchange chambers. But really, you could just talk to some person in line, and you have a 50-50 chance that they want the exact opposite. So you could just trade OTC basically. However, even if we get 100% of trading volume, there's still a significant amount of liquidity that cannot be settled within one batch. And so there will always still be the necessity for passive liquidity provision. And these, Uniswaps, Balancer, whatever these pools are on the blockchain today. And so we don't think we're actually eating away their lunch. We're hoping that we can make Ethereum a better place to trade and actually increase the overall trading, well, capacity on Ethereum, and then also overall still LP providers will still be around for a very long time. We don't see LPing going away for just having cows on chain.
All right. Well then, thanks for all those great questions. Thanks for all those great answers. Thank you.
We will just put a little video after from Aleph.im. We are one of the hosts of the event, so if you want to see it, you can. If not, you can have it.
Was fun. Thank you.
Je peux l'éteindre?
You have too long press.
Wie lang sind these consonant of ones?
Danke, Leute, das war gut, das war cool. Spannend, echt spannend.
Über was für eine Zeitskala geht es? Also wenn ich jetzt ein Consonant of one habe...
Sorry, we can evict
sorry,
eine Stunde.
It was fucking on the video, like
yeah,
you cannot see Felix when you put the lights because it's everything is blurry. So.
I thought it helped because when I put that, but yeah, because it's like exactly.
I put the video.
Yes.
The internet is broken. What used to be a decentralized network powered by millions of self-hosted servers is all but gone. Today, every image you share, every video you watch, every form you fill, flows through centralized networks controlled by just a handful of companies. But there's a change coming, a monumental shift, and at Aleph.im, we're supercharging the transition to a new decentralized era. An era that provides fully decentralized cloud storage, computing, and identity services, powered by incentivized self-hosted servers. Built from the ground up, our unique architecture blends both off-chain and on-chain technology to support an ever-growing constellation of blockchains and companies. We've built the tools that allow you to store any file of any size on our proven decentralized network. Protect your precious NFTs securely on our network for eternity with our pioneering backup DApp. Unleash the power of our decentralized virtual machines, allowing you to run dApps in any language that can also read and write to blockchains or be triggered by off and on-chain events. Be empowered to store, build, and launch incredible things in this new era of decentralization. Join us at